Okay, last section in this 10.8. It is shape of distribution. Yeah, last section. 10.8. It's just going to be how you look at certain. So you can see we did histograms, and you might have seen some of them that look like this, or any shape really. But there are certain ones that that you can see an actual pattern. So if you look at A, C, and D in those, you can see there is some sort of general pattern in them. B seems to be a tiny bit more all over the place. But A, C, and D, and there are names for these types, okay? And it's important that you do know these. So it's just a bit of notes really today, and you'll see the questions aren't that difficult. So, symmetrical distributions. So, distribution that has an axis of symmetry down the middle and is called a symmetrical or distribution. So, if you take down symmetrical distribution as your first subheading and draw a histogram that is generally that shape, and you can draw that line to show that it's symmetrical. And you can see that the mean, median, and mode will all be in the same place there if it's symmetrical. The mean equals the median, the mode. So if you take down these two little diagrams. One of the most important symmetrical distributions is the statistics and normal distribution. Now we'll come back to that. Real life examples of symmetrical normal distribution are the heights of random sample of people, the intelligence. So normal distribution happens when you have a large sample. So don't worry too much about that. But these two under this subheading. Next one, a positive skew. Okay, so positive skew is when most of the data is to the left, and it's sort of positive. Skew means it's sort of not balanced. Okay, it sort of points to the right, so the tail is to the right. So if you try to remember it as, so there's obviously going to be positive and negative skew. If you try to remember it as positive, it sort of points to the right. It points in the positive direction. Most of the data is at the start. So under your positive skew, take down that yellow box. Take down a diagram that looks similar to this. Doesn't have to be exact. Don't have to have all the same, but this general shape, tail to the right. And then this sort of tells you that the mode, you can obviously tell the mode is going to be at the peak, but the median is going to be here and the mean is going to be generally here. Okay, so it's just going to be, not exactly, but just it's going to be greater than the mean. So the mean is greater than the median, is greater than the mode in this particular case. Because remember, the mode is the most, the median is halfway through the data, and the mean is add them all up divided by how many there is. Okay, so that's positive skew. Negative skew, again if I just zoom in, is the other way. Most of the data is to the right, and if you remember negative, it sort of points to the left. It sort of points to the left. So when a distribution has most of the data at higher values, we say the distribution has a negative skew. When a distribution has a negative skew, the tail will be to the left. So tail facing towards the negative direction. That's how you remember that. So take down that, again a general shape, and this, the mean, the mode will obviously be the point, the median in the middle, and the mean will generally be to the left, because we've got loads of values here to the left. It's more squashed here to the right, so the mean will be here. So the mean is less than the median, less than the mode. In a distribution with a positive skew, the tail is to the right, and a negative skew, the tail is on the left. That's how you remember it. Well, that's how I remember it. Negative skew, tail pointing to the left, to the negative. Positive skew, tail pointing to the right in the positive direction. So you should have three different subheadings with a couple of notes and a couple of graphs in each of them. Some of these are common sense. Fourth subheading, uniform distribution. Just do that sketch. I think that's pretty much self-explanatory. In a uniform distribution, the data is evenly spread. Right. So if you saw a bar chart or a histogram where they were roughly the same, you could say that it's close to uniform distribution. If there's a couple that are high up, you can, but if they're all about the same, that's fine. Bimodal distribution. So here's what I just mentioned before. Distribution is two modes. So if you see most of the others are the same or lower, and then you've got two high points, it's a bimodal distribution. The distribution has three or more modes, it is to be multimodal. Again, we generally don't concentrate on that. And distributions and standard deviation. Okay, and again we'll talk more about standard deviation in 6th year. But we've done a bit in this section. In distribution A, most of the data lies between 2 and 5. In distribution B, the data is more spread out. But look, they have the same mean. but two totally different graphs, because we have extremes on the left and the right, and they sort of, I won't say cancel each other out, but they cause the mean to be in the middle. Whereas here, most of the data is in the middle, and obviously this causes the mean to be in the middle. So the more spread out the data is in the distribution, the greater the standard deviation will be. In the distribution above, we conclude that B has a higher standard deviation. So remember, standard deviation is the distance that most of the values are away from the mean. So you can see here, most of the values are going to be close enough to the mean, so a low standard deviation. In this particular graph, all of these values out here are really far away in comparison to the mean. Okay, so the standard deviation of this one's going to be a lot bigger. Now, they wouldn't ask you to find the exact standard deviation with lots of data, but if they just asked you to comment which standard deviation would you think would be bigger, it's obviously this one. These ones are further away from the mean. The more spread out the data is, the greater the standard deviation will be. In the distribution above, we conclude that B is high. That's what I've said. In the two distributions C and D below, the mean mu is given in each case, 6.2. From the diagrams, we can see that more of the data is further from C than in D. So if you say they haven't pointed at the mean, they point at mu is 6.2, so you can see it's somewhere around here. So you can see a lot of the data is around there. But in this, if it was 7.3, you can see that the standard deviation is going to be greater in C, because 7.3 is roughly halfway between 6 and 8. This is further out where the high points are closer to the 6.2 here. Alright, so there's 6 little sections there. Again, I would put down these two and comment that they have the same mean. For the 6th point, they have the same mean, but B has a greater standard deviation because more of the values are further away from the mean. Alright, and then we're going to ask a few questions. I'm not going to do any examples. There's no examples in the book. What I'll get you to do is try a few of these questions on page 409 to 411, I think it is, and then we'll be finished with section 10. Any questions, please ask.